Hey, welcome everybody to today's Security Week webinar. Really exciting topic and something that on the media side at Security Week I've noticed has been more of an issue over the past year or so, and that's APIs. Today's program is about API MythBusters, the 5 myths putting you at risk. We're happy to be here with Salt Security. My name is Mike Lennon. I will be the moderator today. Just a couple quick things before we get started. This will be recorded, so if you'd like to watch it again or share with colleagues, you'll be able to do that. Everybody will automatically get a link on demand who has registered. Additionally, the reason we do these live is to keep them interactive. Today, oftentimes we save Q&A for the end, which we will save a block for, but also we're going to try and get through questions throughout the presentation. So if you see something or think of something, please do submit your questions. We want to keep the dialogue going and have some fun today. So I'm not going to take up too much time. I'd like to introduce our speakers today. We have Curtis Simpson. He's a Chief Information Security Officer at Armis. He's joined by Michael Isbitsky, Technical Evangelist at Salt Security, and Michelle McLean, VP of Marketing at Salt Security. So, Michael, I'm going to go ahead and pass it over to you, and I'm looking forward to today's session.
Thank you very much, Mike. So yeah, as Mike said, I'm Mike Isbitsky, Technical Evangelist with Salt Security. I'm not going to spend too much time on intro because I really want to get into the meat of this, but I've been in the space for close to a quarter of a century now and focusing on API security very heavily for probably the past 5 years or so, and application security probably for about 10 years beyond that. Curtis, I don't know if you want to do a really quick intro. I know we're going to kind of touch on your experiences as we get through this, but.
Yeah, sure. Just quickly, as was mentioned, I'm Curtis Simpson, CISO at Armis. It's similar to Mike, been in the industry for over 20 years now. Most of my time spent on the enterprise side of the house. So some of the feedback that I'll try to provide today is from both perspectives, both in terms of working for a security solution provider, as well as for working for a Fortune 54 organization.
Perfect. Thanks, Curtis. Yep. So the presentation today, right? We're going to be talking about API security myths, particularly talking about 5 of the most common that really kind of impede organizations as they aim to protect their APIs. APIs are kind of that vehicle for all of your data exchange, but also your business functionality. So let's dive into this. If you are familiar with APIs, typically this is, practitioners are on different points of the learning curve of APIs. It's not a new concept, right? We've had APIs for decades at this point. It's kind of modern design. But what has happened is, APIs have accelerated, right? In design, publication, they're everywhere. It's kind of how we create apps, but also how we exchange data for everything we do in modern society, and certainly in pandemic and post-pandemic times. So for some of us, it can kind of feel like a car crash, right? There's so many of these things, and if you are in the field of security, it's really tough to kind of get a handle on what are all the APIs, where are they my responsibility, what's the exposure, what's business criticality, risk, all these things, right? And you're doing this on top of all the other security problems you're faced with. But what really has led to this explosion of APIs? I mean, there's quite a few. We've detailed some here. You're certainly seeing a lot more of API first approaches. Amazon, you could say, is potentially one of the first that came to this space with that kind of mindset. Not just with the e-commerce site, but certainly the cloud services, right? Everything they build is API enabled and API first. But that has also led to kind of API product mindsets, right? I'm not building, an application or some piece of machinery. The API itself is actually the product or service, right? That's the thing of value I'm building. So we've started to see API product teams as well. Customer demand, right? And that's kind of been a driver to things like digital transformation and agile methodologies. Expanding partner ecosystems, right? We're seeing a lot of very expansive supply chains, as well as attacks, unfortunately, right? But that's kind of how we do business, right? We connect with partners. You can't do everything. So in order to, kind of move fast in business, you trust your suppliers. usually connect with APIs. Faster time to market, right? We need to build solutions and deliver them rapidly. Functionality reuse, right? This is kind of the name of the game with development anyway. You want to kind of build something that has reusable purposes for other apps and business use cases. You don't want to create one-offs. APIs are a good way of accomplishing that. Microservices architecture. Typically microservices are those kind of inner communications, and then we might expose that as a web API. We're going to talk about that a little bit later. But microservices architecture has really also fed this kind of explosion of APIs. And rapid innovation, right? It's kind of that same digital transformation side effect. Curtis, did you have any to add? Or are you seeing, like, for you, like in your business, what's really driven APIs?
Yeah, it's really been, I guess you could consider it applicable to the fourth bullet point, expanding partner ecosystems. So prior to the pandemic, we had a handful of APIs, right? It was sooner around using existing products in your stack to integrate with our solution to be able to manage policies without having to get into our console and things like that. It was really managing our console without having to get into our console. But if you look at what happened as a result of the pandemic and everyone going fundamentally remote, we had to reprioritize a number of planned integrations with other products in security stacks. Why? Because a lot of the assets that we would typically monitor using our solution were no longer in traditional networks. They'd now gone remote. So we needed to build out a significant number of integrations that, again, were already planned, but we needed to prioritize those integrations for immediate development. And what ended up happening is we ultimately went from 10 or double digit number of APIs, say around 10 to 20, to triple digit APIs within a period of months. So at that point, for us, the risk really became a lot more material and became something that was prioritized not only in terms of how we were building our product, but the risks that we needed to manage from a security perspective in order to continue to allow for the product evolution, but to not worry about what that might do to our brand or the product itself.
Absolutely. Yeah, it's kind of been my experience too. Like what I would see talking to organizations is they might start with tens of APIs, right? It was kind of a known quantity, and they might rely on VPNs to restrict things. Those APIs resided within data centers, but as we shift those things to externalized cloud environments and connect to partners, it's those APIs multiply and the connections rapidly multiply as well.
Well, in a more traditional enterprise environment, the other experience very much falls into the microservices architecture, because I'd commonly say digital transformation equals microservices, which equal APIs. Because you're rapidly moving from these traditional legacy platforms to these slivers of capabilities that are now being consumed entirely through APIs. So that level of growth we're seeing, as you noted, from many different perspectives, and it really depends on what your industry is, how you service your customers, how you enable some of those capabilities, and how you need to move away from some of that traditional tech to some of the more modern tech.
Mm-hmm. Yep. So very quickly, agenda for today. I believe you're going to get these slides after the presentation. So if you want to go back, it's a kind of an easy referenceable table of contents for you. But without further ado, let's kind of dive into these so we have time for discussion. The first we're going to talk about is zero trust. I'm sure many of you that have connected in today, you've heard of zero trust. Not necessarily a new concept, right? It's kind of a evolution of least privilege, and it's kind of trust but verify, right? We can't necessarily trust the computing environment or connections, right? So we have to continuously evaluate, is this connection legitimate? Should we drop it? Zero trust, though, has kind of become overloaded as a marketing term. It often maps to many technologies, but including things like microsegmentation or maybe zero trust network access. But ultimately, it's kind of this evolution of network security, but particularly network access controls. So let's kind of talk about why is zero trust, not API security, putting aside those philosophies, and we'll talk about that in a second. But if you think about network access control approaches, even in a lot of security thinking, training, they'll talk about this concept of the walled castle, and you have your moat, and you're going to build defense in depth. Like, you want to prevent somebody from getting into the castle. The problem is, with APIs, that's an issue, because your APIs need to be, you need to allow access, right? Like, that's the whole point. You want to enable functionality, you want to exchange data. So a lot of network access controls kind of fall over very quickly. Port 80 and 443 need to be open if you are firewalling things. So network access controls don't always help you, particularly for those things that need to be internet facing, or if you're building public or open APIs, they just really don't do much of anything. So connectivity, right? That has to be present. We also see many API attacks where it's in trusted and authenticated channels, right? A lot of scraping attacks, they're taking advantage of an authenticated session, right? It's a legitimate user, but maybe rate limits aren't in place, right? Or that API is exposing more data. It's still an authenticated API call. So these network access controls, it's there, but it's very difficult to track kind of the internet, the wider internet, and all the potential consumers, when you start getting into these public API use cases. And APIs are usually consumed by machine identities too, right? Not just user identities. So you can't necessarily challenge a machine like you would a user, whether that's a consumer or an employee. Automation's kind of the name of the game, and unless a machine's been programmed to kind of respond intelligently to that challenge, it's going to break your API behaviors. The other big downfall we usually see with zero trust based technologies is that the metadata you need to inform them, particularly at scale, like Curtis was talking about, the explosion of microservices, and usually that's in the scale of hundreds or thousands. It's very difficult to kind of tag and label all of your code, right? It gets into version control, but how you construct containers. There's a lot of prerequisites that go into that that you can kind of automate this whole process of informing these new zero trust based access controls. Curtis, did you have any kind of experience on this front with zero trust?
Well, the reality is exactly what you stated, right? If you look at ZTNA or SASE type capabilities that we typically equate with zero trust, those types of solutions are not intended for this type of engagement, right? And as you noted, you quickly run into issues when you look at how APIs are being consumed. And some of the issues that we've run into in past years have been the fact that as we've tried to consume some of these models, it's exactly as you noted. We already have trusted sessions that are being hijacked to then potentially exploit these APIs. Zero trust isn't helping me in that situation, particularly in these machine-to-machine communications, because they're already trusted. That's already been established. The only really relevant element of zero trust from my perspective, and this is where solutions like SALT really come into play, is that continuous contextual monitoring in terms of zero trust. If we break zero trust into the elements that actually allow us to implement a zero trust strategy, the continuous contextual monitoring of how APIs are being used and comparing that against how they would typically be used is a far more effective way of thinking about zero trust in an API consumption model. But again, that's not a ZTNA or SASE-based approach. That's a prescriptive approach to APIs.
Yep. Yeah, and I'd encourage you too, as we get through the session, please submit your questions. We want to keep this more interactive. But yeah, it's exactly what Curtis was describing. And sometimes the other question I get when I was talking to organizations about, how do I protect my APIs? And they might talk about these specific technologies like ZTNA or SASE, or more often it was something like microsegmentation as an offshoot of like a workload protection tooling. We're going to talk about that in a little bit, but there was kind of this, well, we're investing heavily in zero trust because there is a big push for that, right? Like, let's be realistic. It's kind of a big pillar of cybersecurity efforts these days. Does it do anything for APIs? It's a big if. right? Like when you're in that business of creating microservices, you really have to be diligent about it's kind of an offshoot of DevOps maturity, but how you tag things and label them in your pipelines, and then informing the access controls programmatically, right? You can't be in the business of submitting papers and approving ports and IP addresses, right? Things are very ephemeral. It's moving fast. It has to all be machine informed. So they can do some things maybe for inner communications, particularly microservice communications, but for APIs that you expose, those outer APIs and public facing APIs, they're really not going to do much of anything. And we do actually have a reference architecture we're going to show in a little bit that might help kind of hammer this home as well. So let's move on. The next one, this is kind of interesting because I used to see this quite a bit with cloud service providers. Many of them do provide some level of security. We've no doubt seen the shared responsibility models from the big three cloud providers. Everybody has it. It's pretty well understood, I would say, in the infrastructure as a service model. But as you get into things like software as a service or platform as a service, or maybe a container platform as a service, those lines start to blur, right? Like, well, where does the abstractions begin and end? The simplest explanation is you are always responsible for your apps and data. That's kind of been the fact of all of those shared responsibility models, but it's a sliding scale too, right? Of what they'll provide you to protect your applications. Typically it's, they're in the business of selling infrastructure. They'll sell you some infrastructure-based methods that might protect workloads that run apps, but very rarely are they getting into app layer, which we're going to get into in a second. So I mentioned reference architectures, right? And as I was talking to practitioners, this was almost always the case. They'd want to see a reference architecture. Really simplified visual here, right? Because it's, we only have limited slide space here, or slide real estate. But this might be an example of a VPC or a VNet that you're working with. Typically there's many load balancers deployed there, delivery controllers, all types of servers and app servers, including email, which these days, let's be honest, it can be API based. We saw that with the Exchange server attacks recently. But there's many types of services, right, in these inner networks. Typically this might be a data center environment, but now you can kind of reproduce some of that in cloud infrastructure as a service. In the bottom here, though, you see there's kind of these outer gateways and inner gateways. This is typically how organizations publish and mediate their APIs. And then you have inner and outer APIs as a result of that. But I mentioned how, microservices are kind of how you build the functionality and communicate that to inner services. But when you want to expose that functionality to, maybe larger user base or other services, that's where you might build a web API, right? So your microservices might exist within a container platform, typically something like Kubernetes. Maybe you're deep in the world of service mesh, but this can get incredibly complex. And the reality is they're API based as well, right? So there's a lot of APIs. You certainly need to be worried about protecting those APIs you're creating. We talked about Kubernetes, right, or container platforms that can be delivered as a managed service, right? And you may not have visibility into that. It's very easy to spin up a Kubernetes cluster in one of the big cloud providers, right? And standing up Kubernetes on your own with the upstream code, it's very difficult, right? You need a lot of resources to do that. There's a lot of moving pieces. So there's a lot of appeal in kind of subscribing to these provider managed Kubernetes services. Again, this is kind of an unsanctioned environment you're not necessarily going to know about. It's beyond your VPC or VNets. Public cloud serverless, right? So those PaaS environments I was talking about. But in this case, this would be more something like AWS Lambdas or Azure functions, right? You might not even be mediating those API calls. So, the code's going to execute and terminate. So these typical, mechanisms, gateways, you might not even have that at your disposal. And unsanctioned PaaS environments, right? Like Salesforce is kind of an example of this. A lot of times practitioners forget about Salesforce. Many businesses use them, right? Because it is kind of a business critical application. But Salesforce can actually become, custom application development platform as you start getting into Lightning development, what was Force.com. So it's a lot of flavors of cloud, which really leads to kind of this distributed sanctioned and non-sanctioned environments. But the reality with cloud service providers is they're not in the business of really creating app layer capabilities. They want to sell you infrastructure. And if they are creating app layer capabilities, rarely are they going to work across clouds, right? That's just not their business model. They're not going to create something like Amazon's not going to create something that works well for Google or vice versa. It's very easy and cheap to procure cloud compute, right? That's kind of why we see a lot of managed Kubernetes now, as opposed to spinning that up on your own. So it really adds to this problem of, there's too many APIs, and they're likely exposed, but you also may not even know about them because they're not being created and published within your sanctioned environments. Curtis, did you have anything for cloud security on your front?
Not much to add there, but really everything you said is just spot on, right? It really comes back to a lot of the key points that you mentioned. That shared responsibility model is key, and we really should always start there with making sure that we understand our responsibilities, but you nailed it in terms of these infrastructure providers are securing their infrastructure that they're using to deliver these services, but our consumption of those services is our responsibility, period, right? So when you look at the APIs that they're offering us, our use and monitoring around the use of those APIs, configuration of the APIs, all our responsibility. And then as you noted, as you start coupling that with custom APIs, with other third-party APIs that you're consuming that are totally unrelated to your IaaS provider, you need something to rationalize across all of those APIs. And even if the cloud providers, to your point, were providing us with something, it would just be for their services, most likely, or potentially as an extension for some of those commonly used third-party service APIs. So we can't rely upon something along those lines. You've got to rely upon something that, again, allows you to stretch across all those APIs, get that common visibility, common understanding, and establish your control layer based upon that common centralized understanding.
Yep. Yeah, and actually we see this too with a lot of API management, which we're going to get to in the next myth. But yeah, it's very true. The other thing I would say too, that I've sometimes seen with organizations as they get into cloud, they start talking about multi-cloud. There are multi-cloud offerings from some of the cloud providers, but it kind of gets worse, right? Because it's like the things they're giving you today for their own infrastructure are limited. Expect that to be more limited as you get into something like Anthos, right? Google Anthos that might work across cloud, right? So now Google has to actually create those abstractions that work for AWS or Azure, right? So it's kind of you're reducing your capabilities as you move into different clouds. It sounds appealing, right? Because then it's just one tech stack you might have to learn, but the devil's in the details. So don't expect limited capabilities for infrastructure. Certainly worse for kind of app layer capabilities. All right, so let's see if we had any questions that popped in. We did get one, and I think this is going to kind of get answered as we move through the myths, but let me just iterate it now, and then if we need to repeat it, we can. So the question was, how else can I protect an API that's hosted on an IaaS server and accessed through VPN in public domain, besides using username and password, kind of tried and true authentication mechanisms, and using encryption? So I'd say this is kind of it captures the traditional approach, right? And encryption would be something like TLS, and username and password are authentication and authorization. We're going to get to that in the next myth. And VPN is that network access control. So these things work, but as you get into public APIs, you might use something like OAuth to enforce authentication and authorization. OpenID Connect on top of that. There's many different protocols for authentication. We'll table that for the next myth. But what typically happens with these APIs that need to be consumed by larger consumer base, access controls start to not scale, right? So you have to look at behaviors, right? And we're going to talk about this as we get more towards the end of the presentation. So hopefully that helps answer at least partially. And then as we get through these myths, it'll kind of flesh things out more for you. All right, so let's move on. Identity and access management, API gateways, and WAFs are enough. These are the mechanisms we see time and time again. They are tried and true, just like I was saying as I was answering that question. IAM is kind of, when you say API security to someone, often they're thinking identity and access management, right? Authentication and authorization. If they're not thinking that, they might be thinking TLS, right? But these are the things we push in security as kind of the way to protect your APIs. The problem is it's not enough, right? So let's get into why it's not API security. So the first problem, and this really gets into kind of modern API design and microservices architecture, is that they're very reliant on proxying, right? And the more proxies you add into an architecture, it starts to slow down API communication. You're going to start to add latency, which is really a non-starter, right? If your APIs aren't performant, everything falls over, right? The business is going to be unhappy. Your consumers are going to be unhappy. Things just aren't working right. So we have to, we often have to concede how much access control we're doing as a result of that, right? And you kind of see this. Actually, we saw this with Experian recently, where you kind of relax some of your access controls because you want to do business, right? But the problem in that case is really weren't doing enough on kind of the anomalies detection side of the house and runtime analysis to see how people were consuming that API and potentially maliciously. The other reality with, particularly API gateways and WAFs, with gateways usually have something, they'll call it threat protection. They're essentially pre-built message filters. In some cases, the gateway vendor might have implemented a WAF in the gateway, something like mod security, but they're all signatures and rules-based for attack detection, and primarily exploit types of events. So like injection flaws is a really common one, cross-site scripting and SQL injection, maybe XML injection or JSON injection. All of these rules have to be pre-built. So typically what happens is, the rules are lowest common denominator, look for very common malicious characters like a single tick, angle bracket, and just block those things wholesale. That can work for certain types of exploits, but doesn't really help you with business logic attacks or custom APIs that you're building, right? A lot of times those rules are built around commercial and some open source packages, like WordPress, for instance. If you're not building something on WordPress, it's very low value for you. We talk about business logic attacks, right? APIs, I mentioned, they're kind of the thing that facilitates business functionality, and not going too deep in design patterns, but typically, APIs are helping enable your business functionality. And it's very hard to test business logic flaws for APIs, let alone catch attacks against that using message filters and kind of this single transaction view. You have to kind of look at what's the sequence of events with API calls to kind of unearth, is somebody abusing business logic? It's not immediately apparent just by looking at the code or looking at a single transaction. Unfortunately, that's how these mechanisms have been built. API management, we've seen where API management itself is actually vulnerable, right? That reference architecture I showed prior, typically the API management software, maybe something like Apogee or MuleSoft, organizations often front end that with a web app firewall because they know there's likely a web portal, like self-service portal, and that itself can be attacked. And the other is, attackers bypass access controls. I was talking about this on one of the prior myths, but attackers will either authenticate themselves, maybe they'll create dummy accounts, they might compromise somebody else's authentication materials with credential stuffing or brute forcing attacks, or they're going to piggyback on their session, like steal an active session. There's a wide range of network attacks that do that, or they'll harvest things in code, right? And this is a really common mistake we've seen. It's unfortunate that happens quite often, and actually another industry researcher, Alyssa Knight, just did some research kind of the state of mobile healthcare apps that talk about this problem where keys are being embedded in mobile application code and then using that to connect to backend APIs. Things you put in your mobile apps are basically clearly visible to an attacker, right? So it's not a way to authenticate API calls, but this happens more often than not where that key material gets embedded in the client-side code and attackers harvest that. Curtis, did you have anything on this kind of the world of identity and access management, WAFs and gateways?
Yeah, everything you said was very much on point. The reality that I've encountered by tackling this both on the enterprise side and then based on those learnings, avoiding some of that as we were looking at managing risk around APIs within Armis was exactly as you stated. We found that really more than anything else, identity and access management just wasn't a valid control in safeguarding APIs for the reasons you mentioned. Whether it was the fact that we'd noticed patterns in the past where, as you noted, you could either establish trusted credentials within a given app and then use that app to be able to pull data through the abuse of APIs, the ability to steal keys by hijacking sessions and the like. There's a lot of challenges with attempting to use, as you've rightfully noted, IAM as an effective control. But so I don't want to touch as much on that, but I want to talk about WAFs because this comes up all the time. I think as people move forward with implementations, they quickly realize that IAM is not really getting them very far. You're really just establishing some of your private versus public APIs with your IAM controls. But then as you look at the consumption of these APIs and how to protect them, the challenges with WAF is exactly as you noted, they're signature-based solutions. The concerns that I've always had with APIs is around the abuse of APIs, and not even just one, but the set of APIs that we've exposed and how you could potentially abuse APIs to pull information that maybe should or shouldn't have been made available through that API, and then stitch that information together across multiple sessions or across the consumption of multiple APIs. How would I notice that with a WAF? The short answer is I won't. The problem with a WAF is it's looking for those signature-based attacks. So will it tell me that someone's trying to abuse APIs to execute a denial of service attack against my product or environment? Sure. Will it tell me, though, that someone has realized that I've overexposed information through one or more of my APIs, and they're now pulling as much data from those APIs and stitching it together to learn about customers or other information? No, I wouldn't see any of that. That's just going to look like normal usage as far as a WAF is concerned or a gateway is concerned. The reality is that these tools were never built around logic. It's exactly as you noted. They were built around signatures, but APIs are entirely built around logic. They're built to enable specific business outcomes that relate to machine-to-machine use cases, internal consumption use cases, or enabling that customer experience that truly matters most to our customers in the experience they're looking for. So yeah, everything you said is spot on, but just do not, I guess the public service announcement is really watch how many risks you put into that WAF bucket, because it's really only helping you with those common signature-based attacks.
Yep. Yeah, absolutely. Yeah, and I'd say what I've started to see with some WAFs is, how do you improve the signal to noise? Because it's exactly that, right? You stand the WAF up, next thing you know, you're seeing thousands or tens of thousands of events because somebody's actively probing you. But really, it's based on signatures, so it's still only a subset of how somebody might actually attack your APIs. So it kind of adds a lot of noise, and it's not necessarily the way that an organization is going to get attacked or breached, right, or leak information that you shouldn't be exposing in that API.
Yeah, and the more effective modern model is ultimately what we've implemented with SALT and the combination of our existing WAF, because a WAF still has its place. You still want to be able to defend against something like denial of service attack. But the beautiful place to be is where you can monitor logic or the consumption of APIs from a logic perspective, identify anomalies that are concerning, establish policies around that level of anomaly, and then integrate with a WAF such that you can terminate sessions that are risky, malicious, or concerning sessions. And in that moment, you now have that ecosystem that you're looking for. because you've got contextual monitoring telling an enforcement solution that something needs to happen in order to sever those sessions to prevent a potential attack. That's where we need to be versus where a WAF will get you.
Yep. Yeah, it's kind of the benefit of being a proxy deployed in the architecture. But yeah, as we saw in the reference architecture, there's many, right? We have customers that enforce in different spots. That's kind of the beauty of the Salt platform. It gives you that flexibility. I'm going to move on, I think, because unless we had questions, I don't know, specifically for identity and access management. Looks like we had one come in for third-party API consumption, specifically of enterprise Google Workspace, formerly G Suite. And then how do I assess and monitor the risks of these third-party API calls? But then also gave another example of Salesforce APIs. It's a really interesting question, and I'll try to tackle some of it here. I would say if this doesn't help you enough, certainly reach out and maybe we can follow up through email. Typically what we see when organizations architect their apps, there's certainly APIs that product might come with. They're going to build on top of that, right? So you have your custom APIs, but then they might also be calling out to cloud-based services, broadly software as a service. Salesforce certainly fits that model. Google Maps is a good example, right? You might want to just invoke the Map API and consume that data, and then you're going to kind of reform it and do your own mashup, right? Of what the page should look like for your user. So it's really common to kind of have the APIs you're building and hosting and that data and functionality, but you're consuming some other API, third-party API. So the platform does actually assess that, right? The long answer is, your gateways, and this isn't true of all of them, actually need to proxy outbound communications and kind of give you visibility into that. Sometimes, unfortunately, gateways are only mediating inbound calls, right? In this case, you're actually calling out to a third-party API. So provided the proxy mechanism is catching that traffic, we're certainly inventorying it. So, but any platform you look at needs to kind of differentiate. Well, yeah, this is a third-party API call. There is inherent risk in that, right? Because maybe you're exchanging data with it, and that's going to impact your regulatory burdens, but potential privacy impact. Hopefully that helps answer the question. I would say, if not, please reach out. We'll try to get you a more in-depth answer. All right, so let's move on. Talk about workload protection. This is a really interesting one. I used to get a lot of questions on this, in particularly the world of cloud workload protection platforms. Sometimes cloud security posture management, or maybe the new evolution, cloud native application protection. They're very useful tools, particularly as you get into the world of containerized architectures. But they're essentially, it's somewhat of an agent-based control, but it's more like host-based IPS. But in this case, you're either hooking into the hypervisor if the workload's running as a virtual machine, or you're hooking into the container runtime. Right? There's different deployment patterns depending on your infrastructure architecture. But this is this world of CWPPs. Why are they not API security? Well, it's actually some of the things we've touched on already, right? Like when we talk about those infrastructure concepts and abstractions, the CWPPs very useful for governing large numbers of workloads and how they connect, right? So you might have thousands of containers that facilitate microservices, like they're powering them. So they're going to give you kind of that lay of the land. What does the container network look like? Not just my traditional IP network, because that container network is very ephemeral. And they're very useful for instituting guardrails, right? So don't allow anybody to spin up a container that doesn't follow predefined hardened standards. Unfortunately, the standards are usually based on kind of common misconfigurations. Maybe it's vulnerable runtimes, looking for CVE identifiers, so known vulnerabilities in published code. That's only one small piece of the puzzle, right? And it's really just infrastructure. Most of the CWPPs provide very limited app layer capabilities. If they do, it might be a containerized WAF. It's usually something like mod security, but it's only going to give you the context from like that container view, right? And if you think back to those reference architectures, there's a lot of different places your APIs might exist. Not all of them are going to be servicing containerized microservices or that traffic flow. It might be more traditional workloads. So then you get in this question, well, I have to deploy CWPP everywhere, and it's essentially a very limited WAF, right? And we've already touched on why WAFs don't help, because they are signatures and rules based. But that container position is kind of a deal breaker for them. Very good for protecting your container workloads and limiting blast radius, which is kind of one of those things we talked about with zero trust. And they might even enable microsegmentation, right? I was saying that before. So limit how one container can talk to another. But it's very much about kind of this network access control, just mapped more to that workload, right? The unit of compute, which might be a container. Curtis, did you have anything in this world of CWPPs?
Yeah, just that we currently use CWPP solutions in our environment, both traditional as well as some that are actually more modern and allow you to shift left some of the assessment of those configuration issues and such within the pipeline. And the reality is exactly what you described. Really, as I look at CWPs, as you noted, look at them as a cloud-based IDS. That's really what they are for the most part. They're giving you insights exactly as you noted into mostly configuration issues around core services you're consuming within an IaaS platform that based upon your configuration of those services, the corresponding security groups tied to those services, your VPC configurations. It's giving you insights into where you've exposed yourself as a result of how you've configured that landscape. It goes back to exactly as you've noted, though, as we've been discussing here, doesn't care about business logic, doesn't see business logic, doesn't look at code, doesn't really have an app layer view at all. This is infrastructure assessment capability coupled with some monitoring capabilities depending on the specific product that are, again, giving you insights into exposures around virtual infrastructure, the services tied to the virtual infrastructure, the security associated with that virtual infrastructure, and to some extent, potential abuse of that virtual infrastructure. But that's really it. And it's, as you noted, a valuable product, but nothing I've ever looked at as something that's going to help me with APIs, because it's quickly evident when you consume a CWPP that it really doesn't have a view into that world at all.
Yep. Yeah, thanks, Curtis. All right, let's keep on trucking because I want to keep an eye on time. If we have more time for Q&A, we'll certainly circle back. And if you have any questions, feel free to reach out after the webinar as well. We're all here to kind of help you find answers. Hopefully this all platform might be the answer for you, but certainly can help with technical questions and answers. All right, so number 5, this is a big one. Developers will build in API security. And this is a little bit of a spin on kind of the old world of application security, which it's not that old, right? Many of us are still maturing in our application security practices, let alone API security. But there's kind of this perception that developers are going to account for it. They're the ones building the code. It's their responsibility. You see a lot of this kind of surface with shift left initiatives, but also that line of thinking, right? And it's a little bit of an evolution of kind of secure design. If we don't design the thing and code it securely, it'll never be secure. There's a few problems with this. One is it can actually start to create new types of friction beyond just where security is testing things at the end of the SDLC. Development hasn't tested it. What we start to see is that as security teams push too much left, developers actually resist. But there's actually bigger problems than that, and that's that you can't do everything in code. This is kind of a big misconception in industry that you can kind of test everything, right? And you're going to be secure. You just can't do it, right? And we see this time and time again, right? Like I don't think there's a week that goes by that I don't read about a Facebook or Instagram API issue. right? And those companies, Facebook owns Instagram, obviously, but those development teams, they're testing everything, right? And they have very mature DevOps practices, way more than what most organizations would even want to do, right? They're not in that business of creating social media platforms. They test extensively. They still have a lot of issues because problems that surface in APIs, those business logic flaws, they don't surface in design and testing and build time. They only surface as, in runtime, as the thing's operationalized and users are actively consuming it and misusing it. Secure coding and shift left, they're not API security. You can do some things early in design and coding, right? Like do good input filtering, right? Or trust a library that's built to do the input filtering. And that'll hopefully knock out a wide range of injection flaws, like cross-site scripting or JSON injection, right? Like I was talking about earlier, that WAFs might help with, if they've built that rule for, how you've built your APIs. So you can code some of those things into your API code, but a lot of API security controls exist external to code, particularly identity and access management. Encryption services might be external. We also talked about third-party APIs, right? You're not building that code. Salesforce is building it. So how do you shift that left, right? It's not your responsibility. It's Salesforce. This is why that kind of shift left thinking really falls down, right? You can only push so much left. You still have to do the things on the right side because you're going to get attacked in runtime. Unfortunately, organizations fall into this trap of trying to get everything left to get ahead of it, right? Because it's like that thought, well, let's address everything in design time. There's also a lot of problems with build pipeline testing, right? And efficacy of scanning tools. I spent countless hours advising organizations and even running these tools. How do you run a SAST tool or a DAST tool? Just standalone, but then automating that in a build pipeline. How do you get authenticated context? How do you get APIs in the right sequence? There's a lot of issues with doing that testing at scale and fully automated. And even if you can do it all, logic flaws are still out of scope, right? This is a big kind of, it's something most security testing vendors don't talk about, but it's that, they don't test for business logic flaws. They're looking for, weaknesses that follow well-defined patterns that they can test for in code or maybe the compiled code. But custom, business logic, it's just not something they can check for, right? And that's what I was saying, the Facebook example is a good one. You can test extensively. They've probably written their own tools to test APIs. They're still having business logic flaws and being actively attacked. The reality is API security strategies, yes, you could do some things left. There's importance in doing that. You kind of knock out the low-hanging fruit. But you really have to have good runtime capabilities, particularly fast attack detection and response, not just build pipeline tooling. Curtis, I think you had some experiences with kind of shift left. Did you want to share anything?
Yeah, this is definitely one of my favorite topics. I could probably spend 30 minutes on this slide alone, but it's interesting. And you touched on a lot of the key points. I think one of the first things that's important for us to remember is, and I talk about this just in general in terms of shifting left, not in terms of APIs specifically. Shifting left is about changing mindsets and culture more than it is about consuming specific tools and building them into a pipeline. I think it's incredibly important for us to remember that. And what's also important for us to remember is what Michael noted. As we're shifting that mindset and that culture, we have to do that one step at a time. And typically that's going to mean things like package/container scanning capabilities within your pipeline, right? You want to make sure that, to Michael's point, you can identify those easy to identify patterns like specific CVEs that exist within specific packages that you're intending to build into this product, or that you've got package issues that you should address and update them alongside the changes that you're promoting in relation to this current update. As we think about those types of capabilities, we've got to very much take a crawl, walk, run approach work with teams like DevOps and R&D and development on helping them understand why we're shifting left, then starting to take some of those basic patterns, like I said, typical vulnerability scanning, but now at a package/container level within that pipeline, get through some of those challenges, work through that model, then start looking at SAST and DAST, get through some of those challenges, come out successful at the end of that, and then continue to look at what else makes sense to shift left depending on our business models. But as you noted, Michael, the challenge you're always going to face in this realm, and was something we learned really early on as you started looking at what APIs we're building, the risks associated with those APIs, and our general concerns, is we realized exactly what you noted. None of these solutions are going to allow us to identify logic issues within the APIs and then allow for those to be bubbled up to a developer before they promote the code. That's just not the reality of what's going to happen. We're not going to understand most of those logic issues until we identify those in runtime and production. So our model for APIs in terms of shifting left has become a continuous re-education program, right? We're already doing that with developers anyways as part of changing mindsets and culture in terms of continually building better training for developers around how they should code and those common pitfalls to avoid and how to avoid those pitfalls. So what we're looking at now is what are we learning from the consumption of our APIs in terms of how they should be consumed, how they are being consumed, and then what needs to change in terms of how we code APIs. We're capturing that information from runtime and bringing it back into what already exists, again, as part of our continued closed loop process to change mindsets and culture, which is continually educate, right? Continually educate, provide contextual insights into why we're delivering that education, and solve those challenges in that front. And I think it's important for us to remember, how challenging is it to continually to maintain functional testing capabilities within our QA function that allows us to test everything about our product always? That panacea doesn't exist. And I think we've all come to that conclusion that that panacea doesn't exist. I know I came from an enterprise environment that had automated testing always bolstered by manual testing of specific capabilities that were highly critical when we would execute very extensive changes within that environment. And we couldn't get away from it because we could never keep up with the constant changes being made to the product in an iterative, agile-based manner, and the functional testing that needed to be done to validate every single one of those capabilities and that it wasn't disrupted through our changes. As we think about that challenge, the same is true with APIs. Right, because the same reality exists. We're having to test the use of our applications and whether the use aligns with what we expected, whether it allows for unexpected use, whether it allows for exploitation. And again, it's not possible to manage all of that within a QA function, let alone something that would constantly be learning about your environment, building that into logic that's being assessed as you've shifted left, providing those insights to developers that are looking to promote code. Heck, just saying it sounds like nanobots flowing through my bloodstream, identifying what issues I might have. Like, it's just as future sci-fi right now as that is. And I think it's important for us to remember that, and again, relate it back to some of those functional challenges we've had for decades in the testing realm in general.
Yep. Yeah, really good feedback there, Curtis. Yeah, and it kind of echoes what I've seen too. Typically when I would talk to an organization about automating dynamic testing, I'd inevitably ask them, well, how are you with your QA process and functional test automation? And that answer was almost always not good, right? That's kind of a pillar of DevOps maturity, to be frank, right? And it's a very difficult problem, maybe not even solvable, right? You can't test everything. Code changes very quickly. Who's going to write all the scripts? It's a problem, right? And those are usually prerequisites, including like test data management, to actually automate your testing. The reality going back to Facebook, I know we're not all Facebook, but these companies, they push things to production knowing there might be issues, right? But that's kind of DevOps style releases with canary deployments and the blue-green deploys, which some of these newer tech stacks support inherently. But that's a really big DevOps journey, right? Many years. That's many years for most companies, and they may never get there, or they don't have the business driver to do that. But that's the reality, right? You can't test everything. things are going to surface in runtime. So I know we got about 5 minutes, so I'm going to kind of wrap up with some recommendations. These are going to be very quick, I'm hoping we can get some of Curtis's feedback here. So I'm going to kind of talk about, we've touched on how these technologies don't help, right? Or these approaches, what some of the pitfalls are, why they only do pieces. The reality is you do need something that can kind of supplement these tools, right? Because they're helping for different pockets of security in your organization, but not directly helping with the security of your APIs. So the reality is you do need some special tooling. It really has to be continuous, right? Curtis was rightfully pointing out how everything's continuous, right? You have to have processes. It is cyclical. You have these feedback loops where you're feeding back to development, certainly. But it has to have that behavior analysis capability. And it needs to be assisted by, big data, right? You need these massive cloud storage to deal with all this data because it's a lot. But you need a machine assistance, right? No human is going to be able to unearth all of the right signals or useful signals, particularly for every organization's custom APIs. You'll never be able to build APIs or the rule sets for APIs at scale, right? So you need machine learning. That's the reality. The tool that you look at should have very simplified deployment, not require another proxy or agent, right? There's likely way too many of those as it stands. And we didn't even talk about things like endpoint protection, which might even be adding more. It needs to deploy at multiple points of the enterprise architecture, right? Thinking about that reference architecture and all, and even the simplified one, all the places your APIs might exist, you have to have flexibility in how you can deploy any API security tool. And it has to integrate with your existing workflows, right? IT teams are already trying to automate their daily tasks. Working in different systems, you don't want to force them into yet another security tool, right? So any API security offering you look at should have webhooks. It should be API first as well, right? Have all those API integrations so you can kind of it integrates with your workflow and internal IT systems to avoid some of that disruption and friction. Curtis, did you have anything you want to share here?
Yeah, and I touched on it briefly earlier, but I very much subscribe to the belief that our strategy going forward in terms of APIs and everything in our landscape really revolves around contextual continuous monitoring. Right, and a lot of this comes down to the fact as you take a step back just from APIs alone and look at the complexity of our landscapes, highly, highly, highly complex. And we've gotten into this mode now where cyber resilience is really the only effective strategy as we look at securing our landscape, meaning that we constantly need to look at what are our top risks against the things that matter most to our business, and how should I prioritize the management of those risks? And as you think about that, APIs are part of that risk. They're part of the risk from a compliance perspective. They're part of a risk from an exploitation standpoint and the ability to compromise customer data, to compromise your product or your offering, your service in general, affect brand. The issues are real, but context matters, right? That's something I say commonly in terms of security programs going forward. Without continuous understanding of how contextually APIs are being used, how they're being abused, and then being able to act on that abuse in real time through, as we mentioned, potential integrations like with a WAF and being able to sever those sessions in real time. That's the model we've got to be working towards. These APIs are rapidly growing in our landscapes. Listen, the environment I'm in right now, as I mentioned, we've gone from tens to hundreds in a short period of time. The environment I came from went from triple digits to 4-digit numbers, getting into the many thousands very rapidly. And you're talking about interactions between systems and users with every system that matters to the business. So as we look at everything within our landscapes being stitched together from legacy to modern to be able to deliver against our continuous digital transformation strategies to delight our customers, we've got to consider API strategies, and we can't consider traditional solutions that do not provide us with the continuous context that allows us to understand what we need to do in the moment and how we need to bring that that awareness and information back to our developers to continually improve our operations.
Yep. Thank you, Curtis. You know, and I know we're at time here, so I'm at the risk of getting in trouble with my employer. I'm going to leave you with this slide. I'm going to say, you know, if you have interest in kind of how do we tackle this problem with salt security in the API protection platform, please, you know, check out the website. If you like a tech demo, we could certainly arrange that. But, you know, we address these problems, right? The platform was built to kind of address these inherent downfalls or pitfalls of traditional approaches and really protect APIs as they're being built today. Curtis, did you have any parting thoughts?
Yeah, the parting thought would be very easy to use, very easy to deploy, and very effective in addressing, as Michael mentioned, many of the or all of the challenges that we talked about today, and ultimately enabling the type of solution and strategy that I spoke to. So very much a happy customer of Salt, which is ultimately why I'm here today.
Thank you, Curtis. Again, I am Mike Isbitsky, Technical Evangelist with Salt Security. If you have any questions we didn't get to today, and I think there were some, you know, please reach out. We'll certainly get you the answers. But with that, I'd say thank you for joining us today, and hopefully we'll talk to you in the very near future.
Thanks, everybody.
All right. Thanks, guys. We enjoyed it.